It's now time for us to start working on implementing our chat server. So we have what we think is working code for the chat client. We need to make the server work along with this. So the code that we have in here is going to be useful. I don't want to throw it away. Okay, maybe this last part here. But it needs to be reworked a fair bit. Because the thing that the server needs to do is, it has kind of several tasks to it. One, it needs to be accepting connections. So actually I'm going to get rid of some of those print lines over in the client. It needs to accept connections, and we have this code here, but this needs to happen multiple times. We kind of need to have a loop of these, and we're going to have users. So every time someone connects, they are a new user. They have information associated with them. In fact, we might make a little case class for a user. This user is going to have a name. They are going to have the socket that they have connected with. They are going to have the buffered reader that they are reading input on, and they are going to have the print stream that they are printing to. And so we need to somehow keep a collection of these, and every time that we accept a new connection, we need to ask them their name, and then once they give us their name, we can put them into our collection of users. That's going to be happening in one thread because this accept is a blocking call. So that has to be happening separately. And in fact, even asking them their name can't happen here because you don't want someone to connect and then they never type in a name and they prevent anyone else from connecting. So the asking the name has to be in a separate thread from the thread that is accepting multiple connections. Then on top of this, we also need to be pulling input from all the users. So we have to run through all the users and we have to check to see if they have input, and if they do, we need to deal with it. And then when they give us input, we have to send messages out to the appropriate other users. Okay, so from a high level, we could probably think of this like, so check connections is a good method name for one thing we're going to do here. So I'm going to def check connections. And that is that's the code that's actually going to create the server socket and sorry, let me get things working so I can have our futures in here. So this is actually going to do this code. It is going to make our server socket, and it is going to accept connections, and it's probably going to wind up getting the input and output streams. But all of this needs to happen, well, all of everything after creating the server socket needs to happen inside of a loop. And servers just keep going forever. So we're actually going to use a while true on this and not worry about that. And then we'll put in a little to-do here because we need to ask their name and then add them to our collection of users. Okay. While that thread is checking for connections and adding new users, we need to have the main thread can also be sitting in an infinite loop, and that infinite loop is going to run through all of the users, checking input. Now at this point, before I can write either one of these, I have to decide how we're storing our users. At the very least, I need something that is safe to do for across threads. So I need some type, either I have to use a thread safe collection, or I have to do my own synchronization on things. I'm going to go with the thread save collection, and because I want the ability to do private messages, which will go directly to someone with a name, I am actually going to use a concurrent hash map for this. So users is a new concurrent hash map that takes a string, the username, and goes to a user. Now, and I could just stop there, but it turns out there is the ability to convert collections like this to more Scala-like interfaces. You can put .as Scala, and that will work. We just have to do a little import here. Collection, and there are some Java converters, and you bring those in, and now this is a wrapper around the concurrent hash map that has the Scala type map. So we can treat it just like a Scala map and do all the things we're used to with a Scala map, but it will actually be a concurrent hash map underneath it, and so it will be safe for the two threads to use it. So that means that now we can write some of this code here that's running through all of the users. I can actually do a for loop. If I hadn't done the as Scala, I couldn't do a for loop on this. So the keys are names, the values are instances of our user type, and I can do that on users. And because that code is going to be a little bit longer, I'm actually just going to say do chat on it, and then I'm going to pause. I don't actually want to do this as fast as the computer can possibly do it, so I'm going to sleep for 1/10 of a second. That's fast enough. Our users are very unlikely to actually notice this, and we might not have to do that if we had a very large number of users, but it's probably safe to do. Definitely for anything that we're going to test here on these videos. Okay, so what does do chat do? Do chat takes a user and it is supposed to check to see if that user has input for us, and if they do have input for us, then we should then we want to, well, read it in and send it out to the appropriate other users. If we don't put in private messages, in fact right now I'm thinking of holding off on the private messages, that could be added, could be left as an exercise for the person watching. If we don't do the private messages, then we need to check if the user's in has information ready for it. And in fact, this is something that is kind of useful to do, so I'm going to write another little method here called non-blocking read, and it will take a buffered reader. You can do the same type of thing actually with a raw input stream, and it returns an option of string. Okay, so if there is no input, it returns none. If there is input, it will return the string that was read. So I can say if in dot ready. So if it has input, then I am going to give back some of in dot readline. Else I'm going to give back none. Okay. This is simpler with a buffered reader than it would be with an input stream. The book actually uses an input stream instead, where you check available and then read stuff in. Okay, so inside of do chat, I want to call non-blocking read on the user's input, and then I'm going to actually I'm just going to for each that. So let's call this input. So I got something from this user as input, and I want to tell everyone. We could make it so it tells everyone other than the current user, but we could also make it so it just does everyone. We could also check, we have our client if they do :quit, that terminates them. So we could say if input is :quit, well, then we need to do something that handles taking them out, getting rid of them. That would be user.sock.close and users dot you can do a users, actually I probably could just do users minus equals user dot name. So we'll remove this user from the concurrent hash map that way. Okay. If it's not quit, then I want to say that this user said something and send that out to all the other users. So I need to run through all the users for, again, name, comma, I'll just call it U here, in users. We will do u.out.println of name plus, and let's put a little colon in between there, and then the input that they had typed. Okay, and right now this is going out to everyone. We could put an if around this so it doesn't go back to our original user, but it'll actually make it easier for me to test it with only one user, which will be helpful at the beginning. Okay, we're going to break here. We're going to come back because we still need to make it so that we can make our connections. Then we can start testing this and see how things work.